In this example, we have a car going around a curve. This is a bird's eye view. We're given radius of the curve, mass and speed of the car, static and dynamic coefficients of friction between the tires and the ground. And we want to find, does the car slide out of the curve? So first step is draw a free body diagram. If this is a front view, the car is moving towards us, then we know that weight of the car points down, normal force points up, centripetal force points out of the curve, and the friction force is trying to hold the car in. Then if we assign the coordinate frame, say x out of the curve, y is perpendicular, then we need to write the force equations. So in the y direction, sum of the forces in the y equals 0 because the car is not bumping up and down off of the surface. So that equals N minus mg. N equals mg. And then the friction force, we know F equals mu times the normal force. And should we use static or dynamic here? Well, we don't want the car to slide out the curve. So we don't want it to move horizontally, in which case we will use static. Now, in the x direction, we don't want the car to move. That's why we're using static friction. So, say the x force has to be 0. And that equals centripetal force minus friction force. Well, we don't want it to move, but we have to see, is it going to move? So really, we need to compare. Compare 0 to the rest of this. mv squared over r minus us mg. Now, if the centripetal force is greater than the friction force, the car will slide out of the curve. If not, then we know that the car stays on its track. So if we put numbers in here, then we have 1,000 times 20 squared over 50 minus 0.7 times 1,000 is 9.81. We put that into a calculator, then we get 1133, which is definitely greater than 0. Car slides. It's going too fast for the curve.